Time. Well, I want to thank everyone for being here. Is it working?
Yes, you're doing.
Okay, thank you everyone for being here. My name is Alex Pavlinovic. I want to thank John for that introduction. I also want to thank John Kalbakides and Kirsten Flynn. They are people that helped me with this project. They've literally dealt with countless emails and phone calls and other things for asking them about whales. So I'm grateful to them that helped. I also want to thank the 3 people in the audience here, 4 people and the additional people in the audience here who helped in the project volunteering with the whale research itself. So surprise, surprise, I'm part of the MES program. That's why I'm here. I want to thank the MES program for setting up this presentation. I also want to thank the people that I mentioned. I'm a graduate student at the Evergreen State College, and I work collaboratively with Cascadia Research Collective. And today I'm going to talk to you about our project, Do Boat Activities Affect the Behaviors of the Sounders in Inland Waters? A study on gray whales in the North Puget Sound. Let's see, click. There you go. So first, I want to just introduce you to the Sounders. They are a group of gray whales that come into the Puget Sound or the North Puget Sound every year since the 1990s. And to be Sounder or part of the North Puget Sound feeding group, the whales must have shown up for 2 years. And the reason this is emphasized is this table we have here, provided by Cascadia Research Collective, shows the recorded Sounders. And there have been additional whales that have been in the Puget Sound in other years, but they're not Sounders because they haven't been there for more than 2 years. So I want to point out 3 years to you. There's 1990, which is the year we think that this area was founded by 2 whales. In 2000, the group had increased to about 10 whales. And as of 2021, the group had increased to about 14 whales. An interesting fact is every year that the Eastern North Pacific stock of gray whales faces an unusual mortality event, the amount of gray whales or the number of gray whales that utilize the Puget Sound increases as well. This group is typically in the Puget Sound for 3 months of the year, from March to May. Interestingly enough, in the last couple of years, there's been some abnormalities in the durations. In fact, there is a gray whale right now foraging in the Puget Sound as of yesterday. This group is not known to contain calves or nursing females and is primarily made up of adults. So now I want to orientate you to one of their favorite areas to visit, the Snohomish River Delta. Down here in the bottom right portion of the map, we have Everett. So why do the whales come into this area? Why do the whales come in this area? They do this to feed on ghost shrimp. And this strategy is quite effective for them. In similar studies in the previous couple of years, there have been drone images taken of the whales, which show that the whales put on mass and weight while they're in the Puget Sound. In this image, you can see a whole bunch of white dots. And each one of those white dots shows a feeding pit or the residue or hole from a feeding pit left by a gray whale feeding on ghost shrimp. There are approximately 14,000 of these were counted between the years of 2005 to 2015, which means they're coming in here to feed a lot. I also want to point out another feature. You see that kind of tip of land in the bottom left portion, it's Hat Island, which is where the research or the observations of the whales took place from. So I want to now introduce you to our research question. Do gray whales behave differently when a boat or boats are within a kilometer of a whale compared to when there are a boat or boats not within a kilometer of the whale? And to answer this question, we use dive durations, swimming speeds, directions, and deviation indices. And I'll explain those more in a bit. So I want to introduce you to the tools and techniques used to answer this question. In this image, you can see a yellow big device on top of a yellow tripod, which is a theodolite, connected to a laptop, which is running the software Pythagoras on it. And from knowing the angles given by the theodolite, a reference azimuth, and tide heights, the team was able to record precise locations of whales and boats several kilometers away from the research stand. These 2 data sets were then compared using data analyses. Additionally, you can see in that left portion, there is a third person utilized, which was a spotter, which conveyed information about the dive durations of the whales. This information and this research was conducted from March to May of 2021. So we recorded 3 categories of data: dive durations, how long the whales were submerged for; speed indices, how fast or slow the whales are traveling; and direction and deviation indices, how linear or evasive the whales' paths were. We recorded this information both when there were boats present within 1,000 meters of the whale and when there were not, and then we compared those 2 data sets. So now I want to introduce everyone here, or maybe refresh everyone, about violin plots. This sort of plot is similar to a box plot where we have the median value represented by the black line. There's interquartile range, and then the red dots are meant to symbolize the outlier data. It also is a little bit better than a box plot because it shows the distribution of data a little bit better. I will warn you ahead of time that some of these graphs, there's not a big difference between them. Where we kind of find the interesting stories when we get the data analysis. So here we have the data showing the differences in interbreath indices or dive durations. When we look at the no boat data, we see a median value of 39 seconds. And with the boat data, we have a median value of 42 seconds. Where we start to see a more significant differences when we compare the means, where if there is no boat present within 1,000 meters, then the mean value is 53 seconds compared to when there were boats present, the mean value was 67 seconds. So we have another violin plot here comparing speed. The scale goes from 0 to 15.5 kilometers per hour. The median speed indice for when no boat was present was 2.65 kilometers per hour. And then with boat present was 3.43 kilometers per hour. I should show you that probably. The distribution, though, looks different. You can see the distribution of the data for no boat is lower than where it is for boat. Now we have direction indices. On the right side, we have the no boat data. On the left side, I'll show you in a bit, we have the boat data. The scale goes from 0 to 1, with 1 being a perfectly straight line and 0 signifying a 180-degree turn. For this one, the median values were about the same, but you can kind of see the variation in data is quite more. The variability of the data increases quite a bit more when there are no boats present. Now we have the deviation indices. The scale goes from 0 to 180. 0 signifies a perfectly straight line, and 180 signifies a 180-degree turn. When there were no boats present, the value was lower at 15.9. When the boats were present, the value is higher at 22.8. Also, the spread was much lower when boats were present to when there were no boats present. So now we get into the fun part, the analyses. We analyzed the movement metrics of speed, direction, and deviation indices together, separate from the dive durations, due to a difference in data structure. Behavioral differences between when boats were present compared to when there are no boats present. Behavioral differences between when there were boats present compared to no boats present showed a significant difference between those 2 categories. From this test, we can tell that gray whale movement metrics were significantly different when there were boats present within 1,000 meters versus not. So to calculate the movement metrics when there were boats present within 1 kilometer versus not, like I said, all 3 of those movement metrics were lumped together. We kind of wanted to see which of the 3 metrics had a greater impact on that kind of clump. So the most significant was deviation indices with a value of 0.905. Then the next most significant was a value of minus 0.695. And the least significant was direction indices of 0.266. And the interesting thing here is that deviation indices and direction indices are a measurement of the same variable, so to speak, linearity, and they're different. So after establishing significance, we had a limited number of focal follows. So that's our tracking session. So each of our fixes and dive durations were clumped into 1. And this became a worry for us. We wanted to make sure that we had enough focal follows to show significance, that one clump of data wasn't showing the change in the data significantly. So to figure this out and make sure we had what we needed to do, we used generalized least squares models. And After going through model selection, this process had us create the best fit models for our variables, and the best fit models included boat presence and observation posts. To account for any correlation among focal follows, which I mentioned, focal follows were used as the auto correlation structure for the models. Conclusion. So after accounting for observation posts, gray whale behaviors were significantly different when there were boats present within a kilometer versus not. So we ran the models, we took into account the fixed effects and the other variables, and we found that with all 4 of our variables, the P values or the significance that boat had on our variables was still significant. So even after considering the limited number of focal follows, so even after considering we only had 76 hours of data, we wanted to have 200 hours, we still felt that when boats were within 1,000 meters of the whales, often the whales appeared to speed up, travel in a more linear path, and had a decrease in predictability of their dive durations. So what are the implications of this? We have an image here. In this image, we can see 1 boat, 1 whale. If you're able to pan out, in fact, you would see about 10 boats within 1,000 meters of 2 whales. This draws attention to the important aspect of this study. Research on other cetacean species has indicated that watercraft presence may have adverse effects, such as disrupted foraging, as well as avoidance of heavily trafficked areas. I forgot to mention that while the sounders in the Puget Sound, they interact with several boat-based whale watching operations and countless recreational and commercial boats. So with that being said, and I know I rambled a bit and I apologize, I want to thank all the supporters and partners of this project in the field. Things got a little messy at times and things didn't always go according to plan. There are advances, setbacks, but I appreciate all the help I received. Truly, countless people helped with this project, and I wish I could buy them a beer or something. Specifically, though, I need to thank the Hat Island community who put up with me for 2 months, the MES program, and the Washington chapter of the Wildlife Society funding this research, Cascadia Research Collective for answering lots of questions, and countless volunteers for helping out with the project. Thank you.